Hello folks, today we are tackling Sherlock and the valid string. This is a medium difficulty problem on HackerRank. As usual, I'll go over the problem, give you some time to do it on your own, and then go over my solution. Here we go. Sherlock considers a string to be valid if all characters of the string appear the same number of times. It is also valid if he can remove just one character at one index of the string, and the remaining characters will occur the same number of times. Given a string, determine if it's valid, returning yes, otherwise returning no, all caps. For example, the string ABC, and I think I like how they set it up as like a dictionary with counts for each character. We see this is a valid string because the frequencies are A, B, and C all occurring one time, and so that's valid already. Also, A, B, C, C is also valid because you can remove one of the C's to get kind of the same string from before. However, A, B, C, 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 that's three C's, that is not valid because you can only remove at most one occurrence of the C, which is not valid. All right, so go ahead and tackle this on your own, come back, and we'll go over my solution. So when I first tackled this, I had a difficulty where it had a lot of like if statements, and it was kind of hard to reason about all the possibilities. So I have here in green all the valid strings and in red the invalid strings, as well as the reason why. What we have here is a string with the dictionary, so I'm going to have that be consistent. I think having the dictionary of the counts is actually kind of what you should be doing anyway, but effectively here I'll have two A's, two B's, and two C's, and we see a dictionary. So this is just valid right out the gate. There's nothing wrong with that. Here's a similar situation where we have two A's, two B's, and two C's with one extra D. So this D is the new character, and so we see how here the validity for that is that each character shows up one time except one character which shows up specifically one time. Another situation would be three A's, three B's, and three C's, and then one D. Again, this is the exact same reason. Each character shows up n times, and there's only one character that shows up one time. There's another situation here that they showed us where we have two A's, two B's, and three C's. Here we have each character shows up n times, except one character shows up 1 plus n times, because we can just get rid of one of the C's, and now it's in line with all the others. So if you check out this, we have two A's, two B's, three C's, and three D's. So here there are two unique counts, and by unique counts I mean the 2 and the 3. So there are two unique counts, each of which shows up more than one time. So this is similar to the above situation where we have three C's, but because of that one stipulation where it's like n plus 1, we can kind of handle that. But if you have even one more character that has the same number of count that is like off by, then you can't get rid of it because effectively you have like more than 1 over n to deal with. Another situation is when you have two A's, two B's, and four C's. So this is similar again to this above situation where we had three C's, but now we have like 2 plus n. So here each character shows up n times except for one, which shows up more than 1 plus n times. So if this number was 5, 6, or whatever, anything over 3, it'll be a problem. And this last one, we have two A's, three B's, and four C's. So for this one, you have three unique counts, 2, 3, and 4. And once you get into that realm of having more than two unique counts, then you're too far gone at that point. There's no way to like reconcile having plus 1, because at that point you have more than one count that is more than plus 1. So here's my algorithm that should account for all these possible combinations. I'm not sure if it's actually set up in the best nested logic of like if else statements and conditionals, but it does work. So here's how it goes. So first we need to get our count of each character, so making our dictionary. That's what this is basically. So we need to make our dictionary where each character is a key and the count is the value, and then what we want to do is get the count of the counts. So this is another dictionary which is going to go through the first one and actually look at just the value to see how many times each count shows up. Our count of counts for this, for example, would be a single dictionary value of 2 as the key and 3 as the value, because 2 shows up 3 times. And in this scenario, we would have 2 as the key with 3 as the value, and then 1 as a key with 1 as a value, because 2 shows up 3 times and 1 shows up only 1 time. All right, so once we get through that, we can go through our logical steps here. First, we know that if there is only one unique count of counts, then we can just say yes right off the bat, because that is literally what is valid. So we can return yes right off the bat. So that's one situation taken care of. The other, which is kind of like the opposite, where we know that if we have more than 2 unique count of counts, then we can say no right off the bat. So that's like this bottom situation here. Once you have too many unique count of counts, you're past like a threshold, which makes it basically impossible to like subtract 1 from that. Okay, so then you get into like this muddiness of like nested conditionals. So given our previous logic of these two, the only possible situation left over is that we have 2 unique count of counts. So that's what we have to kind of dissect here. First thing to recognize is if there are no count of counts equal to 1, we can return no. So what do I mean by that? For the situation where we have like 1 extra, for example, this one, and this one, where there's just like 1 little extra there, the count of counts should equal 1. So what I mean by that is like D is its own count of 1, and it shows up only 1 time. Same thing here. For this situation, the number 3 is the key for that count of counts dictionary, but the 3 shows up once. So that value is always, there should always be 1. When that gets violated, then we know we can return no. So that happens in this situation, for example, where the key is 3, but the value for that is 2 in the count of counts. So we know that that's actually not possible. So basically this is saying that if there isn't a single value in the count of counts that shows up only once, then we know we can return no, because we're basically in this situation here. So the next thing to check is if one of the count of counts is 1, like literally the number 1 shows up, and the count itself is 1, that's like these two situations here where the D shows up once, so we can just get rid of it and everything else is fine. So that takes care of these two situations there. So right now we've dealt with 1, 2, 3. We've handled this bottom one, and this logic here has taken care of this one kind of in the middle. So we still have this one to take care of and this one to take care of. If one of the count of counts is 1 and the difference between the 2 unique count of counts is 1, then we can say yes. So that's what this situation here is. That's when we have the count being something that's not 1. So you can't easily just get rid of the whole thing, basically. So you can say, okay, now I have to keep in mind that the count of counts needs to still be 1, which is why 3 shows up only once. And the literal count itself, which would be the key, that number is 1 difference between itself and whatever the other number is, in this case the 2. Then we know that we can make that happen. So that takes care of this scenario. Everything else is just a no. That's basically taking care of this last one. So hopefully that makes sense. I'll go through the code and we'll see how this works out. Okay, so here is my function. It's called isValid, takes an S as the string, and here I have my first dictionary, the count of characters, and this is just a dictionary. I run through each character, adding it to the dictionary and keeping track of the count. The second thing to keep track of is the count of counts. So I'm going to go through that first dictionary, and I'm going to go through the values specifically, and I'm going to add to this dictionary the count of counts. One thing I'm going to do while I'm doing this is I'm checking to see if the length of my count of counts is ever more than 2. I know the second I create a count of counts that goes beyond the length of 2, we know that we're too far gone. So that's basically taking account of this situation here. Once we have more than 2 unique count of counts, we can return no. Otherwise, we get past that point, and we can also check to see now what is the length of the count of counts. Are you 1? If you are, then we can return yes right off the bat, because all the characters have the same count. That is taking care of this situation here, which is like this first one. So that's like kind of like the perfect valid string. Then we get into some murky water where we now have 2 unique count of counts after that point. So here I'm doing a kind of weird list comprehension. This probably isn't the most efficient now that I think about it. Anyway, I'm going through the count of count values, so the actual count of the counts, and I'm checking to see if that value is equal to 1. I'm returning a string. It doesn't really matter here. What I care about is the length of that output. So from this list comprehension, we're basically filtering to see how many values equal 1. If that length is not 1, that basically tells us that there are 2 counts, because we know that there are 2 unique counts after that point. So there are 2 unique counts that both show up more than once, because the value can't be 0. Like this value cannot be 0, and if it's not 1, then it's more than 1, literally. So we know that's not valid. We can return no at that point. So that is accounting for this one here. After this point, we are still left with figuring out these 3 here. And the thing we're looking for is basically like the lower count. So like, for example, the D or the 1 shows up one time, and here the C or the 3 shows up one time as well. So we're checking to see, hey, does this show up one time? So here I'm taking the count keys, just creating a list, and I'm grabbing the keys from our count of counts. We'll now have the min and the max from that. There are only going to be 2 keys given the fact that we only have 2 unique counts to begin with. So the first thing to check is our first logic here. One of the count of counts is 1. And so that's what we're checking here. Is the first value literally equal to the number 1? If it is, that's great because we could just basically get rid of it, but we have to make sure that the actual value is also 1. So we need to make sure that 1 shows up one time. If that's the case, then we can return yes. The next thing to check is the difference between the second and first. The second value is technically larger, so second minus the first, that has to equal 1. If it's not equal to 1, then we know that we're at this point where we have like too much of a distance between the two. Otherwise, if it is true, then we can return yes. Else, no. I'm pretty sure there's a more efficient way of doing this. I might be able to like do something here where I can like grab the key value pairs and then do some sorting or something. There's probably a more efficient way of doing this, to be honest, but you know, it works. And as long as you understand the logic, I think that's the important thing. You can make it more efficient on your own. I'll leave that to the viewer. Okay, so let's run some code. All right, looks good. Let's submit some code. Booyah. So let's go over some time complexity. So the first things first, we're going for each character in this string. So that's big O of n for the first time we pass through it. Technically, each one of those could be unique. So the second time we pass through the values in that dictionary, that also might be big O of n technically at most. And so that is that. Everything else here is just conditional logic. I don't think there's anything that's too much. These values, so the count dot values, we know for a fact that that length has to be 2 at that point. So this, even though we're kind of looping through a dictionary, we have a set amount of length, which is only 2, and therefore it's constant. So I'm not going to have anything beyond that, really. Big O of n plus big O of n, big O of n. So if I had any advice for my younger self, younger being like half an hour ago, it would be to do this step first and to like really hash out all the different possibilities, all these edge cases and things that seem kind of weird, and kind of have my logic grounded a little bit better. I still feel I didn't do great, by the way, so I think that there's definitely some cleaning up I could do on this. Let me know how I could be more efficient with my code. All right, folks, so if this is the kind of content you enjoy, please make sure to like, subscribe, do all the good things, and I will see you next time.